Chapter 7, Day 4. We have another rule, a third rule, called power of a power. Yeah, I know, power of a power. That's actually what they call it, power of a power, rather than exponent of an exponent. It's easier to say product rule or quotient rule, but why they call it power of a power? Because you're going to have a base with a power on it, and then you're going to take that whole base with the power on it, and you're going to power it again. Okay, we're first going to do this out the long way, and you know me, I'm going to make you show your work and do it the first couple times, but then after that, you'll be okay if we can find a shortcut. If you want a to the second power 3 times, you have to do a to the second power, a to the second power, and again a to the second power. That's doing a to the second power 3 times. But yet we can break that down even further and say, what is a to the second power, or a squared? It's a times a. And then this one's a times a. And then this one's a times a. So all together you have 1, 2, 3, 4, 5, 6 a's once you multiply them all together. And it's all being multiplied. So it's a to the 6th power. Now, of course, you would not want to do this if I gave you a to the 12th power to the 4th. Because then you'd have to do a to the 12th times a to the 12th times a to the 12th times a to the 12th. And then you'd have to split up all of your a's. So what's our shortcut here? Our shortcut is you take this exponent and that exponent and you multiply them together. A to the 2, or a to the second, to the 3rd power is a to the 2 times 3, which is a to the 6th. Seems really weird because we already have a product rule. But the product rule was when you multiply, you add exponents. So let me just remind you, you don't have to write this down, but the product rule was when you are multiplying 2 things with the same base, you then add exponents. Well, now with the power of a power rule, we are multiplying. And it's not a made-up rule that somebody made and said, hey, now you have to do this the rest of your career because I made up this rule. No, it came from right here. Just the breakdown. Exponents are nothing more than shortcuts of multiplication. Exponents are just a way of making multiplication a lot shorter and easier. Just like multiplication was a way of making addition a lot smaller. You could do 8 plus 8 plus 8 plus 8 and count 8, 16, 24, 36, or 32, or you could do 8 times 4 is 32. Same thing with exponents. It's an abbreviation or a shortcut for multiplication. So now I'm going to have you write the power rule. This is our third one. That's probably a better way to say it, the power rule rather than power of a power. It says multiply the exponents, keep the base. Multiply the exponents, keep the base. You see a pattern here. We're always keeping the base. Put a big old circle around that. This is now your third rule. We'll have 5 altogether when we're done with this chapter. Let's start with this. And again, if you need time, pause it every time you need to write down the examples. 2 to the 5th to the 3rd power means we take that 2, keep the base. I'm not changing that base at all. My base is 2, leave it alone. 5 times 3, you get 2 to the 15th power. Now, if you were going to actually calculate that, you have a power button on your calculator. It looks like this. It's a little it's called a caret. Some of you have different calculators. You'll have to try to find your power button. If I did 2 power 15, that's it's pretty big. 32,768. Could you write that down? You could. It wouldn't be wrong, but 2 to the 15th is okay also. Most of the time, we don't have numbers. Most of the time, we have a variable for a base. But here's another number. You've got -6. Look at all the mess with, first you have to have parentheses because you have to separate the negative and make sure that that gets squared. And then you'd either use another set of parentheses, or in this case, they switch to brackets to say all of that gets in the 5th. It said power rule, keep the base. So if you keep -6, you've got to keep your base, and it has to be in negatives. Then what do? 2 times 5 is 10. big old shadow on my face again. I feel like that wasn't there before, and now it's there. Oh well. Next up, what about if you had x squared to the fourth? X squared to the fourth power. Now we have a base of x. Like I said, most of the time they're variables. And make sure you take 2 times 4. 2 times 4 is 8. You're probably pretty used to me by now. You'd be like, oh, sweet, this is our assignment. But then I always turn the page, and there's something more to it. Like, what if there's more than one base? We have AB to the third. Oh, that's where the shadow's coming from, probably the screen. Oh, yeah. Okay, so AB to the third power. That basically says, and again, I'm going to have you write the whole thing out so that you get an understanding and where it comes from. That says take A times B once, A times B twice, A times B a third time. That's what the power is, shortcut multiplication. But now we can use the commutative property and rearrange all this and say, well, I want all my A's to be together, and I want all my B's to be together. So A times A times A, and B times B times B. But you would never write your answer with all of that work, so we go back to shortcut. It's A to the third and B to the third. So basically what it's saying, there's more to the power rule rather than just power of a power. Now your power rule also says you have to power everything that's in the parentheses. You have to power the A and you have to power the B. If there were 10 different variables in the parentheses, you'd have to power each one of them separately. Try this one. 24p to the 8th. 24p to the 8th. That means your 24 needs an 8th power, and your p also needs an 8th power. Could you calculate that out? Sure, I dare you. 24 power 8. 24 power 8 equals 1.1 to the 11th power, which would make that about 11 million. A little too big. We don't need to go that big. So leave it as 24 to the 8th and p to the 8th. Try this one. Write it out first, parentheses, 9xy, parentheses squared. We're going to give the 9 a squared. We're going to give the x a squared. And we're going to give the y a squared. Each one gets their own square. Can we simplify this one? Yeah. Let's do it. If you power 9 power 2, or you could just hit 9 squared, it's only 81. I'd say if you have 4 digits or less, go ahead and write the number. 81 x squared y squared. Makes most sense. It's the most simplified. And today we're going to combine positive and negatives right away, rather than waiting an extra day. Go ahead and write this one down. 4 x squared y to the negative third, in parentheses, then again negative 3. Your 4 will get a negative third power. Your x will also get a negative third power, but it's 2 times negative 3. And your y is going to get its own negative 3 times negative 3. Show your work first so you know where these numbers are coming from. 4 to the negative third. It is not negative 12. Trust me, it's a mess. We don't know what to do with negative exponents yet. 4 to the negative third is 0.015625. Not what you're thinking. So leave that alone. Final answer is 4 to the negative third until we learn what to do with those negatives, and you'll get way more depth in Algebra 2. X, 2 times negative 3 is negative 6, and y, negative 3 times negative 3 is positive 9. We have a lot more left. Let's just keep going. The more you see that I do, the more practice you'll get doing notes, and then the more it'll hopefully make sense when you do your assignment. Negative 4z squared. Again, I'll tell you, everything in the parentheses gets squared. So you're going to take a negative times a negative. You have to square that negative. A negative times a negative. And then you're going to get 4 squared, and then you're also going to get z squared. The negative needs to be done 2 times. A negative times a negative is a positive. 4 squared is 4 times 4, which is 16. And then z squared. One other way you could actually do this is you could do the negative 4 squared, but you've got to keep it in parentheses. Negative 4 squared. Don't trust your calculator. Actually, your calculator is right, but you probably type it in wrong. If you type in a parenthesis, negative 4, parenthesis, squared, you're going to get 16, which is what you're supposed to get. But that's because I used the parentheses. What if I didn't use the parentheses and I just wanted to know what negative 4 squared is, like this? That's not okay. Because that's saying I only squared the 4. I forgot to square the negative. So you either have to square the negative by hand and show negative times a negative, or you have to square the negative with parentheses. Because you want negative 4 times negative 4. Not negative 4 times 4. Those are different. So the only way we can get that to work is to put the negative 4 in parentheses. Compare it to this one. Notice the negative is not in parentheses. The negative is not in parentheses this time, so I'm just going to drop it down where it is. There was a negative, leave it alone. 4 squared, z squared. Simplify that since it's a nice small number. Negative 16 z squared. Last one on this page, try it yourself. Go ahead and pause the video, write it down, and see what you get. Okay, you're back. You should have taken 5 squared, x 3 times 2, and y 4 times 2. Simplify that out. 5 squared, careful, is 25. It's not 10. 5 times 5 is 25. X to the 3 times 2, which is 6. And y to the 4 times 2, which is 8. Only the exponents get multiplied, not 5 times 2. That's 5 power 2, x power 3 times 2. All right, a few more, because we actually get to use the power rule with quotients also. We could call that quotients, we could call it division, but think of it that way, that it is a fraction. And the power rule for fractions, everything is in the parentheses, so just like in multiplication, everything gets the power. And then get rid of the parentheses. The a gets the third power, the b gets the third power, the a stays in the numerator, the b stays in the denominator. A to the third over b to the third. Try this one. Negative 7 over x in parentheses squared. Again, you have a negative squared. So you either have to take a negative times a negative, or you can put it on top and take a negative 7 in parentheses squared. Either way is fine. A negative times a negative is a positive. 7 times 7 is 49. So you get negative 7 squared on the top, or, like I said here, negative times a negative. In the denominator, the x also gets a square because it's in the parentheses, so your answer becomes 49 over x squared. Last couple. Pause this one. Try it yourself. See what you got. Okay. Pat yourself on the back if you got a to the 10th over b to the 5th. That's a good job. We've got 2 left. We'll get a little more complicated and then a lot more complicated. Write this one down. 4x to the negative 2 over 5y but then all of that is in parentheses. Everything in the parentheses gets a power. The 4 gets a power of 3. The x to the negative 2 gets a power of 3. And the power rule is to multiply. In the denominator, the 5 gets a power of 3. And the y gets a power of 3. But we got to clean that up a little bit. Find out on your calculator what 4 power 3 is, or 4 times 4 times 4. You should get 64. What is 5 power 3? 5 power 3 is 125. So 4 power 3 is 64. Clean up your x's. Negative 2 times 3 is negative 6. 5 to the third is 125. And the y to the third looks like this. Not too bad if you slow down and just take one at a time and put them in the right spot. Numerator stays in the numerator, denominator stays in the denominator. Last one, write it down, we will do it together. 9x squared over 3y to the negative 5. All of that is to the 4th power, which means we need 9 to be to the 4th power. We need x squared to be to the 4th power, 2 times 4. Underneath that, we need 3 to be to the 4th power. We need y to the negative 5th to be to the 4th power. We'll clean it up again. 9 to the 4th power, and I'm going to actually make you write this down. 65, 61. 9 to the 4th power is 65, 61. X, 2 times 4 is 8. 3 to the 4th power is 81. And y, negative 5 times 4 is negative 20. Don't be done right here. I'm looking at this going like, that's kind of an awful looking fraction right there. Is that really 65, 61 over 81? But if you look back at the original problem, that could have been reduced. Maybe we should have reduced it first. Or maybe we should just check and see if it can be reduced. Can you take 65, 61 divided by 81? What'd you get? If you get a whole number, you're good. I did get a whole number. It's 81. So to clean this up completely, you would have 81 x to the 8th over y to the negative 20th. You don't want a really super big number, an ugly fraction like that. If you can reduce your fraction, reduce it first. Get rid of this 3 and turn that into a 3. You know that 9 divided by 3 is 3. 3 to the 4th power would get you to 81 right away. Either way, you're going to get the same answer, so I'm fine with it. All right, that's it. Work on your assignment, working with power of a power, or the power rule, as we call it. Good luck.